topic 4.7, L'Hopital's rule. And I first want to mention that, I'll put it over here in the notes, that his name was, the mathematician that discovered this, spelled, I'll get this down and then so it's pronounced Guillaume de L'Hopital. So he was a French mathematician in 1661 to 1704. And you can look him up if you want to learn more about him. But we now say L'Hopital, and we put an S in there. We don't say the S. We don't say El Hospital, but we do say L'Hopital. And that is just, I suppose, the Americanized way of spelling it and saying it. But let's get on to his rule. So let's first recall, because this is important. Let's first recall, whenever we evaluate limits, always try direct substitution first. And I'll tell you why. You shouldn't try to do anything fancy right now, because the limit as x approaches 3 of 2x minus 5 over x is just 2 times 3 minus 5 over 3. And that's just 1/3. We didn't have to do anything fancy. We didn't have to do any algebra. We didn't have to do anything. So please try and plug it in first, okay? Now, let's get into using L'Hopital's rule. We're asked to find this limit as x approaches 2. We have a quadratic over x minus 2. What we've learned in the past is plug it in. But if you plug in a 2 in the denominator, you're going to have a 0, and we can't have that. So we knew we had to try algebra or something. So in the past, we have done x approaches 2, and I think this would be x minus 2, x minus 5, all over x minus 2. And so those would cancel out, and we would plug the 2 in, and we'd get 2 minus 5, and we'd get a negative 3. Okay, but what if you wanted to apply L'Hopital's rule? So I'm going to rewrite this limit, the limit as x approaches 2, and let me make this a little or, of x minus 2, x minus 5, all over x minus 2, even if you hadn't factored it yet, even if you hadn't done that. In fact, let's not do that, because L'Hopital is supposed to save us some work. Let's just say we have x squared minus 7x plus 10 over x minus 2. And right away you notice, I'm going to move this 1/3 over just a little bit, because I need to write something just to the right. So this is equal to 1/3, okay? When you plug 2 into the numerator, you get 2 squared, which is 4 minus 14. That's negative 10 plus 10. So right here, we have 0 in the numerator. And if you plug a 2 in the denominator, you get a 0 in the denominator. So what we call this is an indeterminate form. So if you get 0 over 0, you can apply L'Hopital's rule. So you're going to put an H over your equal sign to let somebody know. And if you see it somewhere else without the H, I'm requiring it. So the H over the equal sign means you're applying L'Hopital's rule. Now, you're not going to believe this. You will take the derivative of the numerator, which is 2x minus 7, and the derivative of the denominator. And now you'll try to plug it in to see if that helps. And it does. 2 times 2 minus 7, that's a negative 3. So what L'Hopital's rule says is that If you plug the value in and you get an indeterminate form, 0 over 0 or infinity over infinity, both of these are called indeterminate, indeterminate form. I don't know which one. I didn't even put it there. I think it's indeterminate. If you get either one of those, you can apply L'Hopital's rule. And what L'Hopital says is, if you take the derivative of the numerator and the derivative of the denominator and then look at that limit, it is the same as this original limit. So what L'Hopital says is that the limit as x approaches a of f of x over g of x, only if you have those indeterminate forms, is equal to the limit as x approaches a of f prime of x over g prime of x. There is not a quotient rule. You actually take the derivative of the numerator by itself and the derivative of the denominator by itself. And you may have to do this over and over again. Okay? So let's give it a try. And you can only do it when you arrive at these indeterminate forms. Okay? So let's go ahead and start with number 2 and see what we have here. So as x approaches 2, remember, we're supposed to save some work. So if we plug 2 in the numerator, we know we get a 0. And I'll tell you right now that the denominator is also 0. That's 24 minus 24. Oh, good. So 24 minus 24 is 0. And then 2 minus 2 is 0. So you can check that, but that is 0 over 0. That is an indeterminate form. And this is really, really good notation to let somebody know you found that. Some professors like it written up in the margins just a little bit like that. So what are we doing? We're going to apply L'Hopital's rule. So we have the limit as x approaches 2. The derivative of the numerator is 1, and the derivative of the denominator is 27x squared minus 12x plus 1. Now, you might already be thinking, well, we don't have an indeterminate form now because this is not a 0 or an infinity. So now we really have to take the limit, okay? So if we plug 2 into this, we have 1 over 27 times 2 squared minus 12 times 2 plus 1. And that will come out to be, I think that was 27, yeah. That will come out to be, do that derivative right? I guess that's 9. What is wrong? I've been looking at that and it just didn't look right. That is a 9. I was cubing 3. But that's okay. So it's good that I found it right now, and it's good that I made that mistake with my students because it's good for you to see I make mistakes too. So that looks a little bit better. So 9 times 4 is 36 minus 24 plus 1, and we have 1/13. Now I know you thought that was fun. Okay? Now, 3 should look very familiar. Do you know what the limit is? Remember that the limit as x approaches 0 of the sine of x over x is equal to 1. I know you remember that. But you know what? Sometimes we can't remember everything. So we had to have a 6 down here, and if I did that, I had to put a 6 up there. So this limit is 1, so this whole limit is 6. But we can apply L'Hopital's rule, okay? So not all of us remember those kind of things. So if you plug 0 in the numerator, the sign of 0 is 0. If you plug 0 in the denominator, it's 0. Bingo, we have an indeterminate form. So now I'm going to apply L'Hopital's. And if you don't apply L'Hopital, I don't have an H here. If you don't apply L'Hopital in that step, don't write it, okay? So we take the limit since we have the indeterminate form, and the derivative of the sine of something is the cosine of something times the derivative of the something divided by 1. So we know now we're finding this limit. It's 6 times the cosine of 6 times 0. So it's 6 times the cosine of 0. Of course, the cosine of 0 is 1. 6 times 1, and it is 6. Okay? I think that's a little bit better than memorizing a limit, a special limit. Okay, let's approach 0. In the numerator, we have 1 minus the cosine of 0. The cosine of 0 was 1. That's 1 minus 1 in the numerator. So we end up with an indeterminate form. So we have 0, and of course the denominator is 0. So we're going to apply L'Hopital's rule, limit x approaches 0. And the derivative of the cosine is the negative sign. So what that does is makes the sign positive. So the sine of x all over 2x. Now, what do you notice? The sine of 0 is 0, and 2 times 0 is 0. So we are going to apply L'Hopital again. And you will have to apply it again and again until you don't have an indeterminate form. So the derivative of the sine is the cosine of x. Derivative of 2x is 2. Now, you know we don't have an indeterminate form now because there's a 2 in the denominator. So now we're going to be plugging it in. The cosine of 0 over 2. And then that's equal to cosine of 0 is 1, 1/2. Okay. Let's try number 5. So I'm going to tell you, we used to peek at this, and we used to be able to say that this limit is 0. I don't know if you remember that, but this exponential grows very fast. It grows faster. The denominator grows faster than the numerator. This is a polynomial. So it'll be something, but it won't grow near as fast. So anything over infinity is going to be equal to 0. But let's try to use L'Hopital, because if we can use L'Hopital every time we get an indeterminate form, then we don't have to learn or use as many methods, okay? So let's take a look. I'm going to plug infinity in the numerator. So 2 times infinity squared is 2 times infinity, and 2 times infinity is infinity. So we have infinity over, and e to the 2 times infinity. Maybe I'll write this out. 2 times infinity squared over e to the 2 times infinity. That's 2 times infinity over e to the infinity. That's infinity over infinity. That's kind of where we're headed in this class. So we have infinity over infinity. We have an indeterminate form. So we're going to take the derivative of the numerator and the derivative of the denominator. The derivative of the denominator, e to the something, is e to the something times the derivative of the something. Now, the numerator, I know we can reduce this, but I just want to show you this. If you plug infinity in the numerator, 4 times infinity is infinity. And then we have 2 times e to the infinity, which is 2 times infinity, which is infinity. So what do we have? We have another indeterminate form, infinity over infinity. So we are going to apply L'Hopital again. I hope I remembered that over there. Yep. And we take the limit as x approaches infinity of 4 over. Now let's be careful. The 2 goes along for the right. The derivative of e to the 2x is e to the 2x times the derivative of the something. So it's 2 times 2. And when you're simplifying, you don't want to write that h if you're just simplifying. Now, what do you notice? We have a 4 in the numerator. We no longer have an indeterminate form. So basically, we're just plugging it in. So we have 4 over 4 times e, 2 times infinity is infinity. And of course, those 4s will cancel. But we end up with 1 over infinity, and that's 0. Okay? So L'Hopital is really, really good, and it's fun. But you do have to be careful. You can get carried away. And I'm just going to tell you right now, this is a derivative, not a limit. L'Hopital's rule is for limits only. And not only is it for limits, but it's only for limits when an indeterminate form, arises or appears or is evaluated. Okay? Well, how would you work number 6? Guys, number 6 is the derivative of the sine of 6x over x. We have to use the quotient rule, not L'Hopital. L'Hopital is for, like I said, a limit. So that is the quotient rule. Take the denominator, square it. I do mine a little different and I write it. The derivative of the numerator is 6 cosine 6x minus the numerator times the derivative of the denominator. So as you can see, we've got 6x cosine 6x minus the sine of 6x all over x squared. So this is definitely not L'Hopital's rule. Now, lots of practice. I think you'll enjoy this. This concludes not only L'Hopital's rule, but this whole topic 4.7.